All right, we've got a parabola passing through these points, and we want to write a system of equations to write the equation of the parabola passing through those points. They give us the format here, okay? A parabola has to have an x squared term. It may have a coefficient, might have an x term, might have a coefficient, could have a constant term. It's going to equal y. So remember, if a point's on a function, that means if you substitute in the x, you should get back that y value. So when I put in -1, I should get back 8. So I'm going to substitute in those x and y values to this equation. So when x is -1, that's going to be a times -1 squared. And when I fill in -1 here to this bx, that would be b times -1 plus c. I'm supposed to get back a y value of 8, okay? So that's going to give me the equation 8 is equal to, it's going to be a minus b plus c, okay? That's an equation with 3 variables, so I need 2 other equations with the same variables. So I have other points. Let's try the point 2, 5. I'll put in 2 for x, and I'll put in 5 for y. Let's see what we get. So 2 for x, that would be a times 2 squared plus b times 2 plus c, and that equals a y value of 5, okay? So that's going to be the equation 5 equals 4a plus 2b plus c, okay? And then finally, I'll put in the 3 and the 16. So a times 3 squared plus b times 3 plus c is equal to a y value of 16. So 16 is equal to 9a plus 3b plus c. Okay? What I love about solving these systems, notice these c's here. We can subtract the equations really easily and cancel c. Remember, you pick 2 equations, knock out a variable, pick another 2 equations, knock out the same variable, you'll be down to 2 equations with 2 variables. So I'm going to take the bottom 2 equations. 16 equals 9a plus 3b plus c, and the 5 equals 4a plus 2b plus c, and I'm going to subtract the 2 equations. 16 minus 5 is 11. 9 minus 4 is 5a, 3b minus 2b is b, and c minus c cancels. So 11 is equal to 5a plus b. That's one of my equations. All right? I'll pick another 2 equations and cancel. I guess I'll do these 2. I'll do 5 equals 4a plus 2b plus c, and I'll do the 8 equals a minus b plus c. And we'll subtract the 2 equations. 5 minus 8 is -3. 4a minus a is 3a. 2b, now be careful, minus a -b is 3b, and then c minus 3 is 0. So we get -3 is equal to 3a plus 3b. And we just need to solve this system. I would multiply the top equation by -3. That'll give you -33 equals -15a minus 3b. Your second equation is -3 equals 3a plus 3b. You'll be able to cancel the b's by adding. So the b's are gone. We get a -12a is equal to -36. Means a is going to be equal to 3. If we substitute back into one of these equations, 5a plus b is going to be 11, right? So if a is 3, 15 plus -4 would be 11. So b is -4. And then c, if we substitute back into one of the original equations, if a is 3 and b is -4, that's 3 minus -4 is 7, plus 1 would be 8, so c is 1. And remember, they want the equation of the parabola, so we're filling in the a, b, and c values. So that's y equals, it's going to be 3 is the a value, so it's 3x squared. -4 is the b value, so -4x, and then 1 is the c value, and that is your final equation. Okay? Number 9 and 10. I want to make a table of values. I want to make sure my vertex is in it, so I'm going to use the vertex formula. X equals -b over 2a. Okay, remember a is your coefficient of x squared, b is your coefficient of x, c is your constant. So a is 1 x squared, b is -2, and c is 4. And so the x-coordinate of the vertex is going to be the opposite of b, which is 2, over 2 times the a value. 2 divided by 2 is just 1. So now be careful. Vertex is a point. So you have an x-coordinate of 1. You really need to put it back in to find the y, but I'm going to do that when I make a table. So I'm going to make my vertex point the center of my table. So 1, 2, 3. I'll do a couple of values above 1. I'll do a couple of values below 1. Okay? If I put 1 in my function, 1 squared is 1, minus 2 times 1 is -1, plus 4 is 3. So the vertex is at the point 1, comma 3, okay? Now remember, at this point, this is a 1x squared. You can use the over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7 pattern if you want to. Or you can keep substituting into the table if you don't want to use the pattern. So anyway, 2 squared is 4, minus 2 times 2 is 0, plus 4 is 4. Remember, this is going to be symmetrical about the origin as long as we've evenly spaced it out on either side of the origin. So we should also get a 4 over here. Okay, so that would be that point there, and that would be that point there. And if you put 3 in here, 3 squared is 9, minus 2 times 3, 9 minus 6 is 3, 3 plus 4 is 7. Okay, so we've got the point 3, 7. So 1, 2, 3, 4, 5, 6, 7. And then you're going to have a 7 over on the other side, and your graph's going to look something kind of like that. Notice you go over 1, up 1, over 1, up 3. It'll go over 1 up 5 next, and we've got that little pattern there for the parabola. All right, number 10. Same thing, we're going to do negative b over 2a. The opposite of b is negative 12. 2 times the a value is going to be negative 6, so we get 2 there as our middle value in our table, vertex x coordinate. Let's pick a couple values above 2, a couple values below 2. All right. So in this particular case, if you substitute this in, you got to be a little more careful with this one. Let's see here. All right, so if I put a 2 into the function, I get back a value of 5. So 2, 5 is going to be the vertex 1, 2, 3, 4, 5. Okay. Notice that it's being multiplied by negative 3, so it's going to be upside down. So instead of increasing by 1, 3, 5, 7, that pattern gets multiplied by negative 3. Instead of 1, 3, 5, 7, it would be negative 3, negative 9, negative 15, and so on. Or you can just substitute into the function and get those values. So the function is going to decrease by 3. That's going to take you down to 2 on either side of that. So we go over 1 down 1, 2, 3, over 1 down 1, 2, 3, over 1 down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so your function is going to look something kind of like that. And again, you can substitute in. If you substitute 4 in there, you get negative 7 because you're going down 9 from 2. And then you'll get a negative 7 over on this side too. So you can substitute in or you can use the pattern. Either one will work and get a nice graph.